If I asked you to pinpoint India's most dramatic, towering waterfalls, your mind probably jumps straight to the north. You picture the jagged, snow-capped peaks of the Himalayas, assuming that the highest mountains must produce the biggest drops. But that assumption is wrong. We are taught to memorize geography like a grocery list, matching names to states in a textbook, which obscures how the landscape actually works. To truly map India's water features, we have to look past the coordinates and investigate the mechanical forces that dictate why they exist. This chart shows textbook rankings for India's waterfalls. Kunchakal Falls towered over the rest at 455 meters, but databases now measure only strict 90-degree vertical drops. Since Kunchakal cascades down terrace slopes, its true vertical drop shrinks to 193 meters. Under these modern metrics, the new champion is Meghalaya's rain-fed Noakhali Kai Falls, which plunges 340 meters in a single unbroken line. The mountains didn't shrink overnight. Our scientific understanding of topographical geometry simply evolved. Take a look at this side-by-side cross-section of India's river systems. North, rivers rolling off mountains quickly hit flat plains, but the southern plateau is built from ancient rock filled with steep cliff edges, the exact geological recipe required to build a waterfall. This rough terrain forces us to clarify what we mean by biggest. If we measure by width, Karnataka's Jog Falls takes the crown. Think of Jog Falls as a massive multi-lane highway. The terrain forces the Sharavati River to spread out across a vast expanse, splitting into 4 distinct wide lanes before dropping. If Jog is a wide highway, Sivasamudram Falls is rush hour with heavy, crushing traffic. Here, the priority isn't width, but volume, an immense, dense weight of water being pushed over the edge every single second. The unforgiving, hard terrain of the south forces rivers to perform extreme feats of geometry, stretching them out into vast curtains or compressing them into immense volumetric weight. When extreme volumes of water collide with different types of rock, the geological results are violent. In Madhya Pradesh, the Narmada River acts as a continuous, high-pressure cutting tool against solid marble. Because marble is so dense and rigid, the heavy water hits it with such force that it physically atomizes. The droplets shatter into a permanent, thick, smoke-like mist, creating what is known as the Dhuandhar effect. Move east to Chitrakoot and Chitragat, and the physics change entirely. Here, the sheer volume of the rushing water carves out the softer center of the rock face faster than the harder edges on the sides. Over thousands of years, this uneven erosion pattern carves the cliff into a massive, sweeping horseshoe shape. This horseshoe curvature mirrors the geometry of Niagara Falls, demonstrating a universal geological mechanism driven purely by fluid dynamics and rock density. Make no mistake, waterfalls are active, mechanical engines, constantly carving out and dramatically reshaping the entire Indian subcontinent. But what happens when that water has nowhere to fall and nowhere to go? Consider the paradox of Sambar Lake. How does India's largest saltwater lake exist right in the scorching Rajasthan desert, hundreds of miles from the ocean? This 3D diagram illustrates an endorheic basin. Rivers flow into this central depression, but elevated terrain prevents water from escaping. Trapped, desert heat aggressively evaporates the water, leaving behind dissolved minerals and salts through capillary action. The physical result is a highly saline, pinkish lake bordered by heavy, thick crusts of solid white salt. This inland trap is different from a coastal lagoon, like Chilika in Odisha. A lagoon is a VIP room for the ocean, a shallow sea extension protected from crashing waves by a natural wall of sand or coral. Whether they are locked deep in a desert basin or walled off by a fragile sandbar, these water bodies are entirely defined by the physical boundaries that contain them. While some features shape the rock, others preserve the human record. High up in the freezing peaks of the Himalayas sits Rupkund Lake. For decades, the area surrounding this small, pristine glacial lake was a baffling mystery, littered with hundreds of human skeletons. Modern forensics revealed a different story. These weren't soldiers or plague victims. They were a 9th century expedition caught in a freak storm of cricket ball-sized hail. The lake's freezing temperatures simply preserved their bodies in the ice for over a millennium. These remote lakes act as ecological time capsules, recording the violent history of the planet. Geography is never actually finished. Water is engaged in a continuous, centuries-long battle to conquer the land it sits on. That persistence defines human geopolitiks. At Dudhsagar Falls, the massive, churning drop creates the physical and official state border dividing Goa and Karnataka. Water will even erase its own history. This animation shows how an oxbow lake forms. When a winding river suddenly cuts a straight path during a flood, it abandons its old curve. This leftover scar is exactly how Wular Lake in Kashmir was born. The next time you look at a map of India, try not to see a static collection of blue lines and dots to memorize. Recognize the map for what it is, a living, violent, and beautiful story of water fighting rock and winning.